All right. So you said number 5? All right. So tell me what kind of function is it in general? Absolute value. And it looks like that's going to be my next question, right? So pretend it's an equal sign just for a minute, right? Because we're just going to graph it first. So what does the 6, what does it make it do? Left 6. What's that? And down 4. So I know right out of the gate. Let me erase some of this random markings here. I know this much already. Go 1, 2, 3, 4, 6. I know my vertex is right there. Okay. Is this thing doing this or is it doing this? This or this? How do you know? Like the A, right? It's positive, right? So that means it's smiling. Kind of like the quadratic. It's just a more rich smile.
Just want to let you know the 10th graders got back about 12:35 or so, and they've gone to lunch. So give them a few minutes to eat for lunch. They'll be back in class. Thanks.
All right. So what is the actual A value particular? 1. So remember the absolute value? That actually happens to be the slope, the positive and negative one of my line. So that's how I'm going to draw those lines. Now, this means something. Does that mean dotted or solid lines?
It's going to be dotted.
Dotted, yeah. So it's going to look like this. I'll do this in a different color. So I hope you copy in and make sure you understand it as you go. So just a quick recap. So my vertex is -6, -4. It's dashed lines because of the inequality symbol. Now I got to figure out, should I shade all below the function or should I shade up here? So how do we go about figuring that out? Yeah. When's the only time you can't use that? Right, yes. If something's going through it, even if this thing was shifted over just a little bit, if it was going through there, I couldn't use it. So, good. Man, y'all gonna kill this. This is great. So, 0, 0. So the f of x, remember that just means y? So, absolute value of 6 is? 6. Mm-hmm. So, this statement I have, 0 is less than 2. True or false? True. So that means
The solution is on the right side.
all that. And if I were to extend this graph on out even further, that means that everything up underneath the function itself is going to change. Make sense? Okay. So let me ask you, what's one thing that would change if that was less than or equal to? Solid lines. What if I changed it to a greater than? What would happen then?
It'd be false.
So where would I shade in that? So like all that right up there?
Yeah.
Okay, I think you got the idea. Good. Is there another one you want me to look at with you?
Can we do 6 just to be sure?
6? No, I want to leave 6 for you.
Can we do 7 since I wasn't here Monday?
7? Maybe.
And then the top of the 6. Oh, answers, guys, answers.
Answers.
Like how you yell it at. Bro, that's for real though. That's for real.
You'd be the guy like out on a deer expedition. Deer! There's a deer right there! There's a deer! You're like, yeah, we know that. All right, so let's look at it. So, what form is it in? Standard or vertex form? Standard. So standard form, so they want me to find the vertex, axis of symmetry, domain range, and graph the thing. So, over there on my wall, axis of symmetry. So that negative b over 2a thing. That's the first step. I want to find it. Now, what does that B and A correlate to?
B is the negative
Just the negative 2, not the x, but the number in front. Right. What's the A?
It's the x squared.
1. The 1. So we plug all that in. Pay attention to your signs. Notice how I'm putting the negative 2 in parentheses? Because I remember the sign that goes with it. Go ahead, Anderson.
Okay, on the -2, like right outside the parentheses, there's a negative.
Yeah, because that negative right there. Negative b over 2a, so negative times the b value, which is negative 2.
Equal what?
Mm-hmm. All right, so that is my axis of symmetry, x equals 1. Okay, so what first thing I'll do on my graph is I'll go over here and find x is equal, or x is 1. I want to do a vertical line. I know, right? That's going to be my axis of symmetry. So I know this much right out of the gate. This function, well, actually I know two things, don't I? Is it smiling or is it frowning?
It's smiling
Smiling. What tells us that?
because it's not negative.
What's the A's not a negative? Yeah, yeah. So I know this much, and I know somewhere on that axis, somewhere on this axis, is where it's going to lie, right? The question is exactly where it is, right? So I'm going to go figure that out. We're going to take the x value, plug it back into the equation. So y equal, but this time instead of the x's, we put 1 in there. So I come up with negative 8. So my vertex is 1, negative 8. So let's see this. 6. Oh, wow. Right there at the very, very bottom. So I know from there it's going to do this. But we don't want to just randomly draw the curve. We want to try and make it right. So we make a T-chart. Do y'all remember the trick I showed you? How to make them?
2, 3.
Truthfully, only 2, right? I mean, you can do more, right? But so put the vertex in the center of your T-chart. So I go 1 unit this way, I'm at 0. If I go 1 unit this way, I'm at 2. You know, like just kind of like that. So 0, 2. -1, and 3. Okay, so let's do the 0. I think that's going to be the easier one. So if I put 0 in for it all, that makes that all 0, minus 0, -7. That worked out nice, didn't it? I'll blow that up a little bit for y'all can. Okay, so then I take the, I'll do the -1, so it's going to be what, -1 squared minus 2 times -1 minus 7. So -4. That's going to make this one right here -4. So really I only had to do 2 points and I got 4 points out of it. It's kind of nice going the lazy way out of it, ain't it? So, 1, 2, 3, 4. Oh, oops. Whoopsie. Went too far there. There's your graph. No, and we could keep adding points if we wanted to, but nah, it's fine. So what's our axis of symmetry? Remember it's an equation. X equals 1. What's the vertex? 1, -8. Domain.
Oh, real numbers.
Mm-hmm. What's the range? -8 to infinity. So does the -8 have a bracket next to it or a parenthesis? Bracket, yeah. Any question on that? Yeah, is it making pretty good sense? I know it's easy when somebody's explaining it and it makes sense, but when you do it yourself, it can be a little more daunting.
8, 9, 10.
Oh, I didn't mention this earlier, but and you probably already knew it though. Right here, you want to make sure you got your vertex form and your quadratic form. Which again, you already know them, I'm sure, but but you still want to make sure you get those in case you do forget.
What about number 20?
On the very end of the packet, I am. Yeah, I'm what I was going to answer y'all's questions first, but I was going to that next. Yeah. What were you asking? Or was that what?
Yeah.
Oh, what she said? Okay, so number 9, by the way, do y'all feel confident with these type?
Just go over.
Do it? Okay. So, what form is it in?
What was that called? That is the quadratic.
Well, it's a quadratic function, I know that. But what? Remember, there's 2 forms, right? There's a standard form and there's a vertex. Vertex, okay.
Oh, I got it wrong!
So, right out of the gate, I can tell several things about this. One, I know what the vertex is. -3. Remember when you pull that number out, it changes. So your vertex, -3, 2. I also know what my axis of symmetry is. It's what? -3. X equals -3. Remember, it's the h value, the -3. Oh, what else can I tell? I can tell if it's smiling or if it's frowning. How do I know that? Yeah, that one that's right in front of here, right? Okay. So, never even touched the graph, did I? I already know 3 very important things. So, -3. There's my axis of symmetry. -3, 2. It's right here. I know it's going to be doing this, so I've got it in my mind what it probably should look like. So we'll do -3, 2. I'll do -4, -5, -2, -1. And I'll evaluate for -2 and -1 because they're just smaller numbers. And I got the pen, I get to do that. So it'll be -2 plus 3 squared plus 2. So that's 3. So that makes this 3. And that'll make -4, the y value 3. Okay, so So really the only things we need to answer up here on this right side, we answered the first 2. Oh, what's the domain? Mm-hmm. Range? 2 to infinity. True. In truth, you really could answer it without ever even graphing it, couldn't you? That's pretty dang good, the fact that you're seeing that now. That's good. Yes. True. Right. The instructions say graph. Yeah, graph. But no, the fact that you're getting to where you can see, I don't even have to look at a graph. I can look at the equation and know. That's a big step. That's really good. Okay, was there another one particular?
Oh, yes.
You said on the later the 20s.
That was, yes. Have we learned that yet?
Not technically, but I can show it to you. It's actually not big at all, and it's very easy to understand.
Oh, is this going to be on the test? 120? Okay.
Maybe, and I don't know if I told you all this. Okay, so in your study guide, there's some of it I'm Xing out. The 16 through 19, it's saying convert to vertex form. Just because this week, the way I've been out and all that, I just wasn't able to get to that like I wanted, and we need to move on. So that I might come back at a later time and show you, but not today. So you can just X that out. Number 20, you can X it out.
Oh, this solves most of my problems.
However, leave 21. 21's a good little piecewise. It's not a hard one, but it's a good one.
I think one of these was on the benchmark test.
Really?
I think so, yeah.
That blesses my heart. And do you think you got? Wait, well, there was one. I know there was one of them that had like a domain restriction, and most of y'all got it right. And I'm like, yes.
I think I got that right.
I was very happy to see that.
Yeah, there was one like 24.
All right, so let's look at number 25 here. Well, no, I want to do 26 because it's a quadratic. We're in the mode of that. So the 26. Let's real quick just get some stuff off that. So that's it's going to be x equals -8 over 2 times -1. -8, -2, 4. So 1, 2, 3, 4. Yeah, it's in standard form. So. Oh yeah, and like I said, given some more time, I'll actually show you how to take standard form, convert it to vertex form, and you can do that every time. The way this week fell, and I'm going to be out tomorrow, and I really wanted to try. I wanted to try to stay on pace.
Do you know who your sub is tomorrow?
I do. I ain't telling you. I want to leave it a mystery.
Isaac, who is it?
Give us a hint. Is it one that we like?
Oh, I'm sure you love them all. Because remember, y'all are on camera too, so you don't want to incriminate yourself.
Imagine he gets us up and he's like Kevin Hart.
I do not think.
Alright.
That's the main point.
Alright, so let's see. This thing is going to go downward, so it's going to look something along this line. So, alright, so in general, it's doing this.
Pardon the interruption, I need the following students to come to office: Alex Easterwood, Jesse Boyle, Malachi Cheney, Landon Walter. Please come to office immediately. Thank you.
All right, so you'll go through, you'll get it all graphed, all the stuff you already done, you know what to do. So the parent function is a quadratic, right?
Yeah.
So if you look on my wall, if you forget, what's the parent function of a quadratic? X squared. So first thing I'd write down, f of x equals x squared. What's the domain of this thing? Yeah. All right, now, don't answer fast. Think before you speak. What's the range? Negative infinity to 4? To 2. To 2, yeah. It's easy to get those mixed up. So, negative infinity to 2. All right, now here's the new thingy. Number of roots. We're not talking about hair roots or tree roots, right? So the roots are found wherever a function hits the x-axis. So in this case, there's 2 of them, right? It's the function is literally hitting the x-axis twice, right? So, just to mess with you for a second, tell me this. How many? 5? Yeah, there's 5. That's how you, when you're looking at how many roots are there, that you just look how many times does it hit the x-axis. Now, in our next unit, we will look for the precise number, like what is the actual root. But that's another story for another time. Now, this whole end behavior mess. So, end behavior is literally looking at the ends and looking how they behave. So, this right here is going forever in the negative direction, right?
Yes.
So, this one also is as well up here.
Yes.
Okay, so to just get the premise down here, excuse me, that's down and down, right? If one was one was pointing up and one was pointing down, I would say it's an up and down. Does that make sense? I only have one person shaking their head. The rest are not seeing this. I'll say it again. In fact, I'll use this one up here, just because. So, in behavior, I'm looking at the ends. Okay, so this right here is pointing down. That one's pointing up. So, in this case right here, both of them are pointing downward, aren't they?
Yes.
All right, so now they're pointing downward, going towards what?
Negative.
Negative infinity. Right. So, just for the sake of notes here, that's a down and down. So it's a down and down. Now, how that can translate to this weird script is this. As my x values keep going this way, this graph's going to keep going down and down and down, right?
Yes.
And it's going down to what? Negative infinity. So, as the x values get bigger, the f of x or the y's are going to a negative infinity. A down on this side too, right? So, as my x values keep going this way, the thing keeps going down, right?
Negative infinity.
It's going negative infinity again. No, not a lot of weird mystery there. That's it.
Wait, how do you get number of roots?
Huh?
How do you get number of roots?
Hits twice.
Oh, okay.
Yeah, at this point, how many roots? I'm just saying, hey, how many times that thing hit the x-axis? That's all. Yep.
That was all
I need to think.
that was all
So like, what if you accidentally swap them one day? Like, what if one happened to be like,
Up, down.
yeah, one up down?
Okay. Here's a way to remember it. So, going to a positive infinity on the x-axis means I'm going this way, right?
Yeah.
So I'm looking at the furthest right end behavior. In this case, it's down, right? When an x value approaches negative infinity, I'm looking this way, right? I'm looking the furthest in behavior this way, which is this way. Does that make sense?
Yeah, I got it.
All right, now here's the last two, the increasing and decreasing intervals. Y'all good? Hey, give me just give me a second. I'll come to it. Increasing intervals, talking about this. It's like the domain reading. You're reading left to right. So this thing, if I'm coming from this way, it's increasing, right? Think of it going uphill, right? And then right here it stops. Stops increasing, right? So my increasing interval is I'm reading left to right. Where's this thing going uphill? It's coming from a negative infinity to 4. And I'm going to put a bracket. Now, some math teachers will argue, should I put a bracket or parentheses? Because right here, am I increasing or decreasing? I'm not. I'm kind of in limbo, right?
Yes.
So some will argue parentheses, some will say bracket, whatever your teacher at the time tells you to do, just do what they say. I'm fine with you putting a bracket. I don't care.
What if we forget and we accidentally didn't put a bracket?
You'll be destroyed. No, I'm just kidding. Not really. I'm not super picky, but just know that from teacher to teacher it sometimes varies. Just do whatever they say.
So that's just
Yeah. All right. So decreasing from here forward, right? Yes.
So it'd be a 4 negative infinity, right?
No, 4
Or infinity.
to infinity. Right. So the further I go this way, it's decreasing, right?
Yes.
That's it. So with those, just to wrap it up on that, you go through, you graph it, you get a physical picture of it. Your roots is how many times it hits the x-axis. The end behavior, if you have to, physically write down the words down and down, up and down, whatever, up and up. And read it left to right. Increasing and decreasing intervals, look at it, where is it increasing, where is it decreasing. There's a point at which it turns around, sometimes. Except something like this. Hang on, I'll show you. Does this right here ever stop increasing?
No.
No. So in a case like this, if you were going to write a decreasing interval, you would say there is none. It's always increasing, right? So now, what would the interval be that it's increasing in this case? You read this way. Negative infinity to infinity. That'd be your interval. Okay, so does that bring a little bit of light to those weird things? All right, so rest of class. So here's the thing. I'm going to let you work on this study guide. I'm going to let you work on this thing and kind of prep. And if you have any questions, let me know and I'll help you. Okay? And I'll stop.